Welcome. In this brief video, we're going to go over some more definitions. These can also be found in the online OpenStax book. That book is linked below. Increasing and decreasing sequences. A sequence A is increasing, so that is getting larger, if every term after an, so here we have the nth term, well, the next term needs to be larger. So the nth plus one term is larger than the nth term. For all positive integers greater than, for all integers greater than or equal to 1. This sequence is decreasing if the nth plus one term is smaller than the nth term. So again, here I have my next term, and it is smaller than the previous term for all integers greater than 1. A sequence is called monotonic if either of the above conditions hold. Next, let's discuss bounded sequences. A sequence is bounded above if there exists some m such that a sub n is less than or equal to that m for all n greater than or equal to 1. This sequence A is bounded below if there exists some m so that our sequence is always larger than this value m for all integers greater than 1. A sequence is called a bounded sequence if either of the above conditions hold. Next, we have the monotonic sequence theorem. Every bounded monotonic sequence is convergent. Finally, the comparison theorem. Suppose I have these two sequences, A and B, and the individual terms of A sub n are at most B sub n. And this may not hold right away. You may have to do like a few terms, 1, 2, 3, 5, 8, however many terms out. So at some point, after a certain number of fixed terms, in this case capital N, the remaining terms will always adhere to this inequality. Suppose further that the limit of my sequence A is approaching, suppose further that the limit of A is equal to infinity. So that is, this sequence is clearly divergent since its limit is infinity. Then the limit as n approaches infinity of the sequence B is also equal to infinity, and we can say that this sequence diverges.